In this video, we're going to finish off this lesson by taking a look at the concept of water as amphoteric. In other words, water as being an acid and a base. So when water exists in a beaker of water or in a sample of water, you actually have some water molecules that are acting as acids and some water molecules that are acting as bases. And because you have equal amounts doing this, your solution overall, or your sample of water overall, is considered neutral. But essentially what's happening is you have water giving H to other water. And so some of the water becomes OH minus AQ, and other water becomes H3O plus AQ. And so this happens in equilibrium, where you have essentially proton hopping between water molecules. So your water becomes H plus and OH minus, equal amounts, and it goes back to becoming water. But they're equal amounts all the time, so it's always neutral. So because this is an equilibrium, anytime there's an equilibrium, you can have a K value. And so the K value for water is called the KW, and it's called the ion product constant for water. And the K value, to calculate it, is just make an expression up. It's going to be OH times H3O plus. So you're going to have your OH minus times H3O plus, and what's important to understand is that this is also at a specific temperature. And at a specific temperature, this KW is going to be 1.0 times 10 to the power of negative 14. So what it means that in any solution, your OH and your H3O plus, when you multiply them together, have to give you this value here. Look at that, negative 14. Remember, pH is 0 to 14. And just a couple reminders with respect to this here. If you have a neutral solution, your H plus and your OH minus are equal. Acidic solutions, your H plus is greater than your OH minus. Basic solutions, your OH minus is greater than your H plus. But regardless, what happens is if this goes up, this comes down, and when you multiply them together, you still get this 1.0 times 10 to the negative 14. There is another relationship that exists as well, and we can see that later on, but essentially it's that if you have a KW, you can find that by also doing the Ka times the Kb for a particular conjugate acid, conjugate base pair situation. And we'll see where that relationship exists later on. So having reviewed these concepts, we can try this out here. We'll do a practice problem. And the problem is the concentration of hydroxide ions, OH minus, in household window cleaner is 0.0020 moles per liter at 25 degrees. What is the concentration of hydronium ions in the sample? Is the window cleaner acidic, basic, or neutral? So we have the hydroxide ions here, and we want to find the H3O plus ions. So we know that KW is equal to concentration of OH minus times concentration of H3O plus. And we know that the KW at 25 degrees is 1.0 times 10 to the power of negative 14. I would memorize that number because you're going to use it quite frequently. Now we are told that the concentration of OH minus is 0.0020 molar, and we're told that we want to find the concentration of H3O plus, and we also want to know if it's acidic, basic, or neutral. So we can find the H3O plus by essentially just manipulating this equation up here. So we know that the concentration of H3O plus is going to be equal to 1.0 times 10 to the negative 14 divided by the concentration of OH minus. And so that's going to give us 1.0 times 10 to the power of negative 14 divided by the OH minus, which is 0.0020 molar. So we'll have 10 to the negative 14 divided by 0.002, and we'll get approximately, let's see, 2 sig figs, so 5.0 times 10 to the power of negative 12 molar. So that's the concentration of H3O plus. So we found that over here. And now we have to decide if our solution is acidic, basic, or neutral. So you can see here that the concentration of OH minus is greater than the concentration of H3O plus. So OH minus is greater than the concentration of H3O plus. Therefore, this solution is considered basic. So we did a problem where if you have the OH minus, you can find the H3O plus because you know the KW is OH times H3O plus, which is equal to 1.0 times 10 to the negative 14. That's a relationship you should remember.